Okay, so next we move on to the next part of our vectors lesson. We learn how to use the cross product to actually get the area of the triangles and parallelograms. Okay, so let's see how we are going to do that. Okay, so basically let's first take a simple triangle here. So I'm going to consider here the start. I'm going to consider the start of the triangle here. It starts at the origin. Oh, and then here I have, let's say, the vector A, and here I have the vector B. Okay, so then your task is to use the we are going to find the area of the triangle by actually using the cross product. So let's see how it's done. Okay, so this is how we do it. Now let's say the OA vector. Now when you measure with respect to O, it's of course it's a position vector, right? Do you agree with me? When you measure something with respect to the origin, it's a position vector. So let's say the OA position vector is A and the OB position vector is B. Are you with me? Okay. So how do we, and then let's say the angle between the vectors A and B are theta. How do we normally get the area of the triangle? So we write normally area equals half AB sine C, right? This is the formula we use, half AB sine C. In this case, the sine angle is sine theta. This is what we use, half AB sine theta. Or in this case, it's half the A. By A, what do we mean? A means the length of the vector OA. Do you agree with me? By A, I mean the length of the vector OA, or basically the modulus A, isn't it? And by B, I mean what? The modulus of the vector B, which the modulus of the vector B is what gives me the length of this line. When you take the modulus of a vector, you get the length of that vector. And then into sine theta. Isn't it? Okay, so let's quickly remind ourselves of our cross product rule. What's our cross product rule again? Remind me. A cross B equals modulus A modulus B sine theta into n hat. Now, one thing you need to realize here is modulus A is a distance. It's positive. B is also a distance. Okay. And here your sine theta, of course, sine theta, you get the ratio of the sine angle. And your n hat is what? Your n hat is actually a unit perpendicular vector, isn't it? N hat is not just any vector, but it's a perpendicular vector, and also especially it's a unit perpendicular vector, which means what's the length of this vector? If you take by any chance, if you take the modulus of n hat, what would be the answer? The modulus of a unit vector is definitely 1. Are you with me? So what I'll do here is I'll take the modulus of A cross B. What happens if I take the modulus of A cross B? What happens if I take the modulus of A cross B? Check on this. So what happens if I take the modulus? If I'm taking, let me write it again. So if I take the modulus of A cross B, what happens? Now A cross B is originally modulus A, modulus B sine theta into n hat. So if I take the modulus of A cross B, that means I'm taking the modulus of both these vectors on both the sides, right? So modulus A is anyway a positive figure. I'll take it out of the modulus sign. Modulus B is also anyway a positive figure, isn't it? It's just a length. Sine theta, in this case, theta is either acute or obtuse, isn't it? So sine ratios for acute obtuse is always what? It's always positive, because when we take angles inside a triangle, you either get an acute angle or you either get a obtuse angle. And for ratios of sine for the first quadrant and the second quadrant is both positive, isn't it? This is something you learn in P1. Okay, so sine theta is also positive. Shall I take it outside the modulus sign? So this modulus sign will only then apply to whom? It will only apply to the n hat. So what happens? Who is the modulus of n hat? The modulus of n hat is 1, because n hat is a unit vector. And when you take the modulus, it simply gives the length. Therefore, I get here modulus A, modulus B sine theta. In other words, is what? It's the modulus of your A cross B vector. Do you understand? So then, do you see here that I have modulus A, modulus B sine theta? So that means modulus A, modulus B sine theta can be replaced by what? It can be replaced as the modulus of the cross product of A and B, A cross B. So basically, modulus A, modulus B sine theta is the modulus of the A cross B vector. Is this clear? So basically, if I want to get the area, if I want to find the area of a triangle, what do I need to do? All I need to know is to know these two vectors, OA, OB. If I know the two vectors, what do I need to do? I just need to get the cross product of these two vectors and take the modulus of it and divide it by 2. And that immediately gives me what? The area of the triangle. Let's do an example. Okay, so let's do the first question in exercise 5B related to what we did earlier now. Find the area of the triangle OAB where O is the origin, A is the point with position vector A, and B is the point with position vector B in the following cases. Okay, so they've told you that the triangle is definitely starting from the origin. Okay. So one person here is O. This is A, this is B. So OA vector is vector A. This is vector B. So vector A is given as I plus j minus 4k. Vector B is given as 2i minus j minus 2k. Okay, how do we get the area? So now what do we know about the area? Whenever we have a triangle who has definitely one point as the origin, and if we know the other two position vectors, what do? The area was given by the rule what? So we just now learned. I gave you the proof. It's half into modulus of A cross B. Directly you are allowed to use it. Directly use this rule and get the answer. So what's the first thing you should do? Get the cross product of A and B. How do we get the cross product of A and B? Get the determinant of a 3 by 3 matrix. So I, J, K. The first row is the A vector 1, 1, minus 4. Because A is I, J, minus 4. 1, 1, minus 4. Then B is 2, minus 1, J, minus 2K. So 2, minus 1, minus 2. Plus, minus, plus. So then let's get the determinant. Or basically A cross B. And what do we get here? I times. Remove the row and column with I. What do we get? 1 minus 1 minus 4 minus 2. Okay, removing the row and column. Next one we have negative j. So negative j, removing the row and column with j, I get 1, 2, minus 4, minus 2. And the next one is with plus k. So removing the row and column with k, I get 1, 2, 1, minus 1. So I times, let's multiply 1 into minus 2 is minus 2 minus 1 into minus 4 is plus 4. Be careful here. The middle minus sign is anyway supposed to be here. 1 into minus 2 is minus 2 minus and minus 1 into minus 4 is plus 4. Okay. Then minus j times 1 into minus 2 is minus 2 minus 2 into minus 4 is minus 8. Plus k times 1 into minus 1 is minus 1 minus 2 into 1 is 2. Get the answer. Minus 2 minus 4 is minus 6i. Minus 2 minus minus is plus 8. So 8 minus 2 is 6. 6 into minus j is minus 6j. Minus 1 minus 2 minus 3k. Is this okay? Do you agree with my A cross B answer? Now what do? We need to get the modulus of our A cross B. How do I get the modulus of A cross B? So we get the square and we take the coefficient of your AB vector, A cross B vector, and square it and root it. So minus 6 square plus minus 6 square plus minus 3 square and root the whole thing. Root 81, which means 9. So then now can't we get the area quite easily? So area equals half of A cross B. Who is A cross B? Modulus A cross B is 9. So your area value is 9 divided by 2, 4.5 square units. Okay, can you see how we use the cross product to actually find an area? Okay. Okay, so now I move on to the next part. In the next part, again, we go for the area of a triangle, but this time there's a slight difference. What's the difference? Instead of having one vertex of a triangle becoming the origin, now all three vertices are what? Separate position vectors. So we don't have the origin now. In this particular case, the triangle is made up of three position vectors. None of them are the origin. Okay. So basically here you can see we've given the names A, B, C. Okay. So let's draw it. So how do we get the area in such a case? How do we use the cross product? So this is ABC, and let's say the angle between AB and AC is theta. So how do we get the area now? Basically, what's the rule? Area equals half AB sine C, isn't it? Using the sine rule equation, okay, half AB sine C. Now tell me, what do we use here? Half, who is A and who is B? Who is A and who is B? Obviously, what do we use for? I mean, if this is theta, I mean, you use the lengths of the two lines. Yeah, you use the length of the two lines right adjacent to theta for the A and B, isn't it? So then the length of the line AB should be one of the vectors here, isn't it? Should be one person here, should be one length. So AB length, are you with me? So AB length, half AB into what's the other one? AC into sine theta. Do you agree with me? Area equation is half AB sine C, where A and B are the lengths of the two lines. So here half AB is this length, AC is this length. Actually now, to make it a length, now since A and B are two position vectors, how do we like properly make it a length? We need to put the what sign around this. The modulus, half the modulus of the AB vector should actually give it the AB length. And the modulus of the AC vector actually gives you the length AC, because that's the notation we use in vectors. Right? So when we want a length, we take the modulus of any given vector, which should give us the length. So half AB modulus into AC modulus into sine theta. So this is the equation for the area. Do you agree with me? Okay, so once again, we'll use the cross product rule. So now I told you all, now if you have two vectors A cross B, then it's modulus A, modulus B, sine theta into n hat. You are with me, right? So now instead of AB, what if I tell you to take the cross product of the two vectors OA and OB? Just asking you. So instead of AB, we can write the vectors as OA, OB, isn't it? So if it's OA, OB, how do we write the cross product? It will be modulus OA, modulus OB, sine theta into n hat. Okay, so similarly in this case, you know what I'll consider, looking at what I have here, AB, AC, I'll write the cross product of the vectors AB cross AC. Okay, so these also have this arrow. So how do we write the cross product of AB cross AC using this rule? How does it work? Modulus AB into modulus AC into sine theta into n hat. Do you agree with me? Okay, so this is the way we write the cross product rule. Okay, this is the expansion of using this rule. I used instead of the vector A, AB, and here instead of B, I used AC. Okay, is that clear? Now what do we do? Shall we take the modulus of both the sides? So what happens when I take the modulus of both the sides? AB is already a length, and it's the modulus of a length is definitely a positive figure. So modulus AB is definitely, I can take it outside of the this big modulus sign, because modulus AB is a length, it's positive. And what about modulus AC? It's also positive, it can come out of this big modulus sign. And sine theta, I told you, theta is either acute or obtuse, right? When it comes to triangles, for both acute or obtuse, sine theta is always positive, from because it's in the first and second quadrants, all and sine. So sine theta is definitely positive for the first and second quadrants. And then the modulus mark will only fall on whom? It will fall on the n hat. So what happens here? So I get here modulus AB, modulus AC, sine theta. And who is this equal to? This is equal to the modulus of AB cross AC. Are you with me? So this is again another important derivation. Modulus of AB cross AC is modulus AB, modulus AC sine theta. So then can't I use it over here now? Can't I use it over here now? Modulus AB, modulus AC sine theta, you can clearly see it's over here. So what do we get? Half, instead of writing modulus AB, modulus AC sine theta, I can write modulus AB cross AC, the modulus of the cross product of the vectors AB and AC, and we take the modulus of it. So area is equal to half the modulus of the vector AB cross AC. Okay, so is this clear? And you are not, I mean, I did the proof here. You don't actually need to do the proof in the exam. You're allowed to use this equation. You're allowed to use this equation directly. Are you with me? You're allowed to use this equation directly. Okay, so you don't need to prove anything here. Okay, so I'll move on to question number 2. 2 part A. So this is related to the part that we just proved. Okay, so we are going to use this formula and calculate the area of a triangle. So what do we get here? Find the area of triangle ABC where the position vectors of A, B, and C are simple ABC respectively in the following cases. Okay, they ask you to get the area of the triangle ABC. And they've given you the positions of ABC. ABC, A is 1 minus 1 minus 1. B is 4, 1, 1. C is 4 minus 3, 1. Okay, so what do we do here? The area equation. Do you remember? Do you recall the area equation? When you have 3 position vectors, area was half. How does it work? Modulus AB cross AC. Actually, before I move on more further, is this the only way I could actually write the area? Can't I change this area? Now here you see, I used AB cross AC because in my example question, we worked with the two AB and AC vectors, isn't it? We worked with the two AB and AC vectors. But like, can't I do the same thing by using the BC and BA vectors if I know the angle alpha here? Can't we do it by using modulus BA modulus BC sine alpha n hat? We can, right? We could do it with that as well. So basically here what I want you to understand is, okay, the area equation you can write in multiple ways. So tell me another way to write the area. Now this is centered around the point A. So that's why AB cross AC. If I center it around B, what would I get? Half BA cross BC. Another one, half CA cross CB. So all of these are valid rules. Do you agree with me? All of these are valid. Actually, shall we write it over here? So for this, for the area, shall we write down the for the area equation? Shall we write some extra parts here? Area could be half BA cross BC. Or another formula for area could be half CA cross CB. Okay, so both of these are valid. Okay, shall we try the sums now? So now they have given me the vectors ABC. So I have marked them down. It's time to find the area. So to find the area, let me use the first equation. I could use any one of these 3. Okay, so I'll use the first one. Let's find first one. Now you need to realize when they give you A here, this is the position vector of A. Isn't it? It's OA, OB, and OC are what they have given you. Do you agree with me? The position vectors of ABC are they have given you the 3 position vectors. How can I get the vector AB? Who is the vector AB? AB vector is B minus A. Do you recall this? AB is AO plus OB. AO plus OB is actually B minus A. Do you know what I'm talking about? AO plus OB. So OB is the B, AO is the minus A. So B minus A. Are you with me? Shall I directly use that? So B is 4, 1, 1 minus A is 1 minus 1 minus 1. So what is my AB vector? 4 minus 1 is 3, 1 minus minus 1 is 2, 1 minus minus 1 is 2. That's the AB vector. Then let's get the AC vector as well. AC vector is C minus A. So C is 4 minus 3, 1 minus A is 1 minus 1 minus 1. So 4 minus 1 is 3, minus 3 minus minus is plus, minus 2, 1 minus minus 1 is again 1 plus 1, which is 2. So AB and AC vectors are found. Now what do we need to do? To get the area, I have to get AB cross AC. Let's get AB cross AC. So it's the modulus of 3 by 3 matrix. I JK. So the first vector is 3, 2, 2. The other one 3 minus 2, 2. Let's get the modulus. So here we can put plus, minus, plus. Make sure you mark it so that you will not forget it. Okay, and then this step that I'm doing next is actually optional, where you write the 2 by 2 vector. This 2 minus 2, 2, 2. You could write the answer directly. Okay, so if you are confident and if you are practiced well enough, you could write the 2 by 2 matrix answer directly. So anyway, I'll do in the manual way. I'll remove the row and column with J. What do I get? 3, 3, 2, 2. And plus K times, remove the row and column with K. What do I get remaining? 3, 3, 2 minus 2. Okay, I get here I times, what do I get here? 2 times 2 is 4, minus 2 into minus 2 is minus 4. Minus J times 3 times 2 is 6, minus 3 times 2 is 6. Plus K times 3 times minus 2 minus 6, minus 3 into 2 is 6. So what do we get here? 4 minus minus is plus. So 8I, you get 0J and minus 12K. So basically 8I minus 12K. So that is my AB cross AC. Now what do we need to do? 12K, sorry. Then let's get the modulus of AB cross AC. 8 square plus minus 12 square square root. How much is it? 4 root 13. Okay, the simplified answer. And then we get the area. Area equals to half modulus AB cross AC. So half modulus AB cross AC is 4 root 13. This gives me 2 root 13. Is this clear? Okay, so now we are done with the areas of triangles. Now we'll see how we can use the cross product to get the area of parallelograms. Okay, so let's get the first parallelogram with the origin O, including on one vertex. So I'll take a parallelogram here. So this is O. So this is A, this is B, and this is C. Or we can change and do it. Okay. So what do we know about a parallelogram? A parallelogram is actually what? Made up of? A parallelogram is made up of what? Two triangles. A parallelogram is made up of two triangles. So now I'm not going to do the proof. I'm not going to use the half AB sine C rule. So now we know how to get the area of a triangle, isn't it? How do we get the area of the triangle? Area of triangle OAB. What's the rule we use? Half modulus. This is with O. OA cross OB. Right? I can go with half modulus OA cross OB. Do you agree with me? This is okay. OA cross OB, which means what? This is the area of the triangle OAB. Are you with me? This is the area of the triangle OAB is half modulus OA cross OB. Isn't it? And then since it's a parallelogram, so what happens for the parallelogram area? So we need to multiply the area of a triangle into 2. Just take the area, multiply it with 2. So area of the parallelogram OACB. What's the area of the parallelogram OACB? We need to multiply this half modulus OA cross OB with 2 because there are two triangles. So what happens? The 2 and half cancels and you get what? Modulus OA cross OB. Do you realize what's happening here? And OA, if they say OA vector is A and OB vector is Z, I can say this is directly A cross B. Okay, so let's also do it with a parallelogram that has 4 different position vectors instead of the origin. Get me the area of a parallelogram that has vertices. Yes. A, B, C is the main triangle and D. So get me the area. So first we get the area of what? Triangle ABC. What's the area of the triangle ABC? Half. Remind me, area of triangle ABC will be half modulus AB cross AC. This is not the only way to get the area actually. Even in here, you could say BA cross BC. Even in here, we can say that. We can do that, okay? So then I'll normally go with the AB cross AC, and then so area of ABDC parallelogram is what? You multiply half AB cross AC, you multiply it with 2. So this is the area of the parallelogram ABDC. Is this clear? Okay, actually we can continue a little bit further here to get the show that they have got over here. Do you see what they have got over here? For AB cross, according to the way that they have marked the vertices. Shall we work a little bit? Okay, so they have used the vertices slightly differently than I have used. That's why they've got AB cross AD. So I have used the vertices AB, CD like this. They've used the vertices in a slightly different manner to get their answer as AB cross AD. Okay. So then what do we know about vector AB? If I write it in the form with ABC, we know OA vector is A, right? OA vector is A, OB vector is B, OC vector is C. So basically, I could write the AB vector as what? B minus A, isn't it? AB vector is B minus A because AB vector is AO plus OB, which is B minus A. Cross AC vector is what? C minus A. Then let's open the cross product. B cross C. So first thing I get is multiplying B here. B cross product with C. So B cross C. Then the next one B cross into B into cross of minus A. So minus B cross A. Do you agree? And the next one minus A cross C. And the last one minus minus plus A cross A. Okay, what are the things that we know about the cross product of two parallel vectors? Parallel vectors cross product will be 0. So basically this should be 0. And then we could change the it slightly and make everyone positive by doing what? B cross C minus B cross A can be written as positive A cross B. When you change the sign, minus B cross A is equal to positive A cross B. And minus A cross C should be equal to positive C cross A. So anyway, when we do sums, however, we are not going to go into this. We are going to use, we are going to be using this particular format. This raw format is what I'm going to use. Okay, so I just wanted to get you the things that they have done in the textbook. But when I'm using the coordinates and working, I will mainly be working with these. Is that clear? I will not be going with this, but this is like something like a show that in an event you need to prove, you can prove this. Okay. Okay, question number 5. Find the area of the parallelogram ABCD shown in the diagram where the position vectors A, B, and D are given. Okay, A, B, and D position vectors are given. Let's find the area. Mark the coordinates on the diagram first. So how do we find the? Let's mark the position vectors. So here A position vector is 1, 1, 1. B position vector is minus 3, 4, 1. And D position vector is given to you as 2y minus j 0k, isn't it? Okay, so what's the equation for the area of the parallelogram? Area equals, this time there's no half, right? Directly, what do you get? AB cross AD. Directly AB cross AD. Okay, so let's get the AB vector first. AB vector is equal to B minus A, isn't it? So B is minus 3, 4, 1. Minus A is 1, 1, 1. What do we get here? Minus 3 minus 1 is minus 4. Minus 4 minus 1 is 3. 1 minus 1 is 0. Do you agree with me? Is this okay? And what about the AD vector? Because you can see here it's AB cross AD. According to what we have, you need to take these two sides, right? So what's the AD vector? AD vector should be D minus A. So D is going to be 2 minus 1, 0. Subtracting with A is 1, 1, 1. So what do we get here? 2 minus 1 is 1. Minus 1 minus 1 is minus 2. 0 minus 1 is minus 1. Is that clear? So then let's get the AB cross AD. So I get here AB is, first we'll have to write the IJK, right? The determinant IJK. So here we get minus 4, 3, 0. Then I get 1 minus 2 minus 1. The modulus of the whole thing and put plus minus plus. So we are first getting the cross product of the two vectors. I times I times 3 minus 2, 0 minus 1 minus j times minus 4, 1, 0 minus 1 plus k times minus 4, 1, 3 minus 2. Are you with me? Okay, then let's get the vector. So I get here 3 into minus 1 is minus 3 minus 2 into 0 is 0. Minus j times minus 4 into minus 1 is plus 4 minus 1 times 0 is 0 plus k times minus 4 into minus 2 is we get here plus 8 minus 1 into 3 is 3. We get here what do we get here? Minus 3i minus 4j. 8 minus 3 is plus 5k. So this is the AB cross AD. Okay, so then I want to get the area is the modulus of AB cross AD. So modulus of AB cross AD gives me what? Minus 3 square plus minus 4 square plus 5 square square root. So what do we get here? How much? 5? Can I have the full answer inside the set? Root 50, which gives us 5 root 2. Is this clear? So then let's move to the next one. Question number 10. The position vectors of the points A, B, and C relative to an origin O are, so they've given you A, B, C positions relative to O, and then they ask you to find AC cross BC. Okay, how do we find AC? AC is equal to C minus A, right? So who is C? First, let me write my OA, OB, OC. OA was 2 minus 1 minus 1. OB is, what is OB? 6i minus 2k, right? 6i, 0j minus 2k. And OC vector is 3i, 3j, 0k. So AC vector is C minus A. So C is 3, 3, 0. Minus A is 2 minus 1 minus 1. Are you with me? So I get here 3 minus 2 is 1. 3 minus minus 1 is 4. And 0 minus minus 1 is plus 1. Okay, is this okay? Okay, so then after AC vector, let's get BC. So BC vector will be, BC vector will be B minus C, right? So B is 6, 0 minus 2 minus C vector is 3, 3, 0. Is that okay? So 6 minus 3 is 3, 0 minus 3 is minus 3, minus 2 minus 0 is minus 2. Is that clear? Okay, so I have the BC vector. Now let's get AC cross BC. So AC is 1, 4, 1. Cross BC is 3 minus 3 minus 2. Okay, so then let's get the modulus I, J, K. So this is ABC is 1, 4, 1. This is 3 minus 3 minus 2. So make sure you put plus minus plus. This is I times. Shall I directly write? Are you capable of directly writing now? Or shall I write like this? Minus j times. So I get here. Removing the row and column. 1, 3, 1 minus 2. And plus k times 1, 3, 4 minus 3. Is that okay? And then let's get the modulus now. The modulus of the 2 by 2 vector. 4 into minus 2 is minus 8. Minus 3 into 1 is minus 3. Minus j times 1 into minus 2 is minus 2. Minus 3 into 1 is 3. Plus k times 1 into minus 3 is minus 3. Minus 3 times 4 is 12. So what do we get here? Minus 8 minus minus is plus. So minus 8 plus 5 is minus 5y. Minus 2 minus 3 minus 5 into minus j is plus 5j. Minus 3 minus 12 is 15 minus 15k. So this is AC cross BC. Is that clear? So this is AC cross BC. Question number 10. Okay. Check on this. Okay, so my BC vector should actually be, this is not B minus C, right? It should be C minus B, isn't it? Should be C minus B. So there's a slight error here. So C minus B, let's fix it. Okay, so after finding the AC vector, let's find the BC vector again. Let's find the BC vector now. So BC vector is C minus B, right? Okay, so let's find C minus B. C is 3, 3, 0. Minus B vector is 6, 0, minus 2. Okay. So subtract. Okay, so what do you get here for C minus B? 3 minus 6 is minus 3. 3 minus 0 is 3. 0 minus minus 2 is plus 2. Is this correct? Then we get AC cross BC. So we'll write IJK. So AC was 1, 4, 1. BC is minus 3, 3, 2. And then we'll use here plus, minus, plus. So what do we get here? I times 4, 3, 1, 2 minus j times, remove the row and column. 1 minus 3, 1, 2. Plus k times 1 minus 3, 4, 3. Okay, so what do we get here? I times multiplying 4 times 2 is 8 minus 3 times 1 is 3. Minus j times 1 times 2 is 2 minus minus 3 into minus 1 is minus 3. K into 1 into 3 is 3 minus 3 times minus 3 into 4 is minus 12. So I get here 5y minus 5j plus 15k. Is this okay? So this is the AC cross AB. The answer for the first part. Then they ask you find the exact area of the triangle ABC. So if you want to find the area of the triangle ABC, what do we need to do? Half modulus of AB cross AC. So then use the area part 2, right? Yeah. So actually the triangle was, what was the triangle? Triangle was ABC, right? So then, yeah, now instead of going for with area equal half modulus AB cross AC, what we can do is we can use the help of the part we found earlier. What did we find up here? We found AC cross BC, right? So AC cross BC. AC cross BC. However, there's one thing. Now we have found the AC cross BC product. Okay, but the thing is when you're writing the area, I mean, we write here what? They are using the AC and BC vector. So we need to write what? Half modulus. What is it? CA cross CB. Basically, I mean, we take the point C and we write CA cross CB, right? I mean, we found in the earlier part AC cross BC, right? We found AC cross BC. Okay, but the thing is, when we are writing the rule here, normally what we do is we write, I mean, we take one single point and we write the area from that point, isn't it? CA cross CB. Are you with me? Yeah, the first equation also should be half AB cross AC, isn't it? This should be half cross AB cross AC. Yeah, so basically what you need to do is you just need to select one single point and write the area from that point. So AB cross AC, or it could be CA cross CB, or it could be BA cross BC, as long as you take one point and go around, work around it. Now, what happens here? Now the thing is, I need to use the help of the part I proved above, right? So how can I use the help of the previous part? In the previous part, we didn't get the CA vector, we got the AC. So CA is minus AC. Do you agree? And also, I think in the previous part, we didn't use a CB vector, we used the BC vector. Is that correct? So this is minus BC. I just changed both of them. And what happens? Minus minus plus, and it's basically you again get the same thing because I am turning both the vectors to the other side. Now, the original equation would be CA cross CB. But since I'm turning both of them to the other side, both of them produce a minus and it actually goes out. Okay. So end of the day, even if you turn only one person to the other side also, this wouldn't actually affect because because you're taking the modulus of the vector. The modulus is not affected by the negative sign. Okay. So anyway, I come to this format. So half modulus AC cross BC. How do I find AC cross BC vector is found, right? 5y minus 5j plus 15k. So half, how do we get the modulus? Square of 5 minus 5, 15 square. What do we get here? Half 5 root 5 root 11 over 2. Okay, is this clear? Okay, so I hope it's clear with everyone.